Okay, on this, I'm doing page 195, 1 through 34. We spent a couple days on this last week. Before we did this assignment, we spent a couple days on a worksheet that was basically the same thing as page 195. It just kind of broke it down a little bit more. So, I don't know if you guys have some of you might have a worksheet, some of you might not. But it is the same thing as this assignment, but it does a little bit better job of separating the three parts. So basically on factoring, there's generally three kinds of factoring. The first one I call take stuff out. It's my terms for it. And this will be like number one. We'll talk about this in a second. The second kind is I call it a square minus a square. And the third kind, and that's like number two. We'll talk about that also. And the third kind is three-term factoring. And this would start on number 7 and 8 in those problems. If you look at 7 and 8, you can see that there's three different terms. So those are the three main kinds. On 7 and 8 are the basic kind of three-term factoring. And then when you get to number 10, it starts doing some harder three-term factoring. So lots of variation. This is all from Algebra 1. I know you guys might have forgotten most of this, but it might be somewhere in the back of your brains. So I'm going to write it on the board over here. The three types. And the tricky thing is sometimes you can take stuff out first and then you can do a square minus a square, or then you can do three-term factoring. So anyway, let's jump in here. So there is take stuff out. It's going to be number one. I'll do that. Square minus a square. That's number 2 is like that, and 3 is three-term factoring, like number 10 or number 7. I guess it started. Okay, number 1. Says 3x squared minus 15x. Definitely. Get back to life. Okay, so the question, what can we take out? You should really, on every problem, start with that. Sometimes they call it what's the greatest common factor, what's the biggest thing that can go into both. So number-wise, what can go into 3 and 15? That would be 3. Okay, variables, letters, they both have at least an x. So we could divide an x out also. So you put that outside, and then in parentheses you put what's left after you divide 3x from both of these. So 3x squared divided by 3x, the 3 divided by 3 is like 1. X squared divided by x is x. 1x or just x. Okay. And then minus 15 divided by 3. So 15 divided by 3 is 5. X divided by x basically cancels out. Okay. And we can't do anything else. That is the answer to number 1. If I were to distribute this back out like we did on page 190, what would I get? Well, it should go back to this original thing. Okay, this is called factoring because factors are things that multiply into something else, like 3 times 7 equals 21. 3 and 7 are the factors of 21. Okay, 3x times x minus 5 multiplies to this thing. So 3x and x minus 5 are factors of this thing. They multiply to get that. And this is useful for solving problems like on this week's Monday's assignment. Alright, anyway, that's number 1. I'm going to go ahead and do number 2 since it's the first square minus a square. Okay, by square we don't mean a square shape. I mean a square number. 9, for example, is a square number because 3 squared equals 9. Something times itself equals that. 81 is a square number because it's 9 times 9. X squared is a square number because it's x times x. Okay. If you have a square minus a square, it's going to factor. Okay, it has to be a minus in the middle, by the way. A plus doesn't work. You do 2 sets of parentheses, and you ask, what is the root of this? What's the square root of x squared? What times itself equals x squared? And the answer is x. That goes in the front. And second, what goes in the back? What goes into negative 81? What times itself is 81? Well, it's 9 times 9. But to get negative 81, one of them would have to be negative, right? To multiply negative 81. So you have to make one of them negative. Doesn't really matter which one. If we FOIL this together, guess what we get? This original thing. So that's how you do it. Once you do a few of those, it gets a lot quicker and easier. Time out. Alright, back to the odds. Number 3. 3 is just x squared minus 4. So again, it is a square minus a square. Okay. Technically, we should be asking, can I take anything out of these two? And the answer is no. You should always check that first, really. Anyway, what are the roots of these? What times what equals this? X and x. That goes in the front. What goes into negative 4? 2 times negative 2. That goes in the back. Okay, if you want to check it, you could FOIL that and see if you get that. Number 5. 9a squared minus b squared. Alright, can I take anything out of both of those? No. Is it a square minus a square? Yes, because what times itself equals this? 3a. So it's 3a, and what times itself equals b squared? B and b, so it's plus b minus b. That is that. Alright, number 7. Okay, this is the first example of 3-term factoring. It's got 1, 2, 3 terms. You can't take anything out. It's not a square minus a square. It's got 3 things, so it can't be that. But you're going to start with 2 sets of parentheses. In the front of the parentheses, you're going to say what goes into x squared. That would be x times x. So I'm going to put x is in the front. For the back, you say, what 2 things multiply into negative 63 that could add up to negative 2? So you might remember from your times tables that 63 is 7 times 9. Since it's a negative, though, you have to make one of them a negative. It could be like 21 and 3 or something. That also goes into 63. A lot of times it's the first thing you think of that will work. But which of these adds up to negative 2? Which of these pairs? Well, plus 7 and minus 9 make negative 2. So that will be the right one. Again, if you FOIL this, it should go back to that. You don't have to, but that's how it works. More things go into 63 besides 7 and 9, but this is the only pair that could add up to negative 2. Okay, number 9. Okay, again, it's a 3 term. Does anything come out of all 3? Well, you might say A can come out, but there's no A in this term. You might say 3 could come out, but there's no 3 in this term. So nothing comes out. So it's just like the last one. What goes in the front? A times A. What goes in the back? What multiplies into 9, positive 9, that adds up to positive 6? Okay, well, 3 times 3 multiplies to 9, and it adds up to 6. So it's plus 3, plus 3. Something else that goes into 9 would be like negative 3 and negative 3, and that would add up to negative 6. If that had been a minus right there, that would have been the answer. Alright. If you look this one up in the back of the book, they're going to write it like this. You don't have to do this. A plus 3 squared, since they're the same thing, it's just that times itself. You don't have to write that. Okay, number 11. C squared minus 9D squared. Alright, which kind is this? Can we take anything out? Nope. Is it a square minus a square? Yep. Because these both have square roots. What goes into C squared? C and C. What goes into 9D squared? 3D and 3D. But you have to make one a plus, one a minus. Okay, actually, we need to talk about 12 and 13. 12 and 13 are unique on this assignment. It's a fourth way of factoring. I didn't put it on my list because it only shows up on these two problems. It's called grouping. Basically, if you look at number 12, I'm not going to write it down. You have to look in your book. The outside stuff is going to go in the first set of parentheses. The stuff outside the parentheses on number 12. We're going to put that in our first set of parentheses. And the inside stuff is going to go in our second set of parentheses. So on number 12, what's outside on number 12? And it looks like x and minus 2 are on the outside. So that's going to go in one set of parentheses. The inside stuff is x plus 5 and x plus 5. And they have to be the same on both for this to work. But, yeah. So it's x plus 5 in the other set. Alright? So outside stuff in one set, inside stuff in another set. So number 13 then, what's the outside stuff on number 13? Looks like y plus 2. And what's the inside stuff? Alright. Back to the odds. 15. Alright, what kind is this? 3 terms. 1, 2, 3. This one, it's getting trickier though. 15 is a kind of a major step up. What's different about this one and the other 3 term factoring? There's a number on our first term. So we can't just say what goes into x squared. We got to say what goes into 2x squared. Well, what goes into 2 is 2 times 1. So instead of x and x, I'm going to put 2x times 1x. 2x and x. Okay. In the back, I'm still going to say what goes into negative 13. But I'm no longer saying that adds up to this. Because when there's numbers on the front, you have to take that into account when you FOIL. So, okay, luckily there's only one pair that could go into 13. That's 1 and 13, 1 times 13. Since it's a negative 13, I know one of them should be negative. So it's either like negative 1 and 13, or 1 and negative 13. Okay, so we got a few possibilities. I could put like minus 1 here and plus 13 there. I could put plus 1 and minus 13. I could put plus 13 minus 1, minus 13 plus 1. It's actually kind of 4 combos. Any of those 4. These are the 4 possible things that would work. Really, you only have to check a couple of them. I want to choose one that's wrong so I can show you how to check and see if we did it right here. So if I plug in minus 1 and positive 13, okay, that multiplies to that. Now, to check this, the only way to check this is to FOIL it on these problems. So it's a lot more work than like number 7 is. But you really don't have to FOIL the whole thing. I already know that the first gives me that because I chose it to make it work. I already know that the last is going to give me that. So really, I need to do, instead of all the FOIL, I'm just going to do outside, inside of the FOIL. And if that gives me the middle term, then I know I did it right. But like I said, I chose it so it wouldn't work on this one. So if I do outside, 2 times 13 would be 26x. If I do the inside, that's minus 1x, which equals 25x, which is not the middle term. Okay? So if 1 and 13 don't work, then what we need to do is try 13 and 1. That might work. And actually, it's kind of all we got left, so. Factors of negative 13. One of these you have to make negative, either the 13 or the 1. So let's check again. Outside is minus 2x. Inside is plus 13x. Negative 2 plus 13 is 11x. Which is not quite our middle term. Our middle term is actually negative 11x. This is still good news though, because if we get the right number but the opposite, that just means you need to switch your plus and minuses. Okay, so it's almost as good as getting it right. So you just switch the plus and the minus, and that should do it. I mean, you could check again, but it's gonna work. All right. 7. 5a squared minus 37 minus 17. Now technically on all these we really should be checking, can I take something out first? The only thing that goes into 5 is like 5 and that doesn't go into these, so no, nothing comes out. Alright, again, it's the 3-term factoring. Again, there's a number on the front, so it's the harder version. So what's going to go in the front? What goes into 5? 5 and 1, so it's 5a and 1a. Okay, what goes into negative 72? There are a lot of things that go into negative 72. From your times tables, hopefully the first thing that jumps out is 8 and 9 go into 72. And one of them would have to be negative to make negative 72. So I'm just making one negative. It could be like 6 and 12. It could be, what else? 36 and 2. 18 and 4. Okay, you just got to try all of them until you find one that works. I think it's going to be one of these if I remember right. Okay, so we're going to plug these in and we're going to do the outside and inside, and if they add up to negative 37, we got it right. So I'm just going to, I'll just try my first one, negative 8 plus 9. So if I do outside, that's 9 times 5, 45. Inside is minus 8, which if you subtract that would give you 37. Okay, so I got pretty close. It was supposed to be negative, not positive. So I guessed well. If you guess well, then you get it like on the first try. But really I need to switch my plus and minus around since they're opposite. So now it's minus 45 plus 8, which is negative 37. Okay, anyway, this is the right answer. Looks like same thing on 19. Does anything come out? No. Okay, 3 term. What's going to go in the front? What goes into 8x squared? Well, there's actually 2 things that could. It could be 8 and 1 or 4 and 2. And you just got to try and find what works. Usually I try to find, instead of the extremes, 8 and 1, I start with 4 and 2. Because it seems like books use that more often. But if this doesn't work, we got to go back and try 8 and 1. I'll just tell you 4 and 2 are going to work on this one. So. Okay, what goes into negative 27? Well, like negative 9 times 3, or negative 3 and 9. So let's plug that in there. Negative 9 and 3. If I do the outside, that would be 12. And the inside is minus 18. Which is negative 6. Not very close. Okay, let's try 3 and 9. Now if I do the outside, I get minus 36. The inside is plus 6, which is negative 30, which is what I wanted. So this is the correct answer. All right, 21. Okay, 21 is in the B section, which means it's probably going to get a little harder. 3x squared minus 108. Okay, it is not 3 term, so I can't do that. And remember, we should really ask first, can I take stuff out? On this B section, it's a little harder because you can take something out, and then you can usually do something else after that. What goes into both of these terms? Well, it can't be x because there's no x over here, so it's probably going to be 3. If I divide both of these by 3, I get x squared minus 36. Okay, don't throw that 3 away. You got to keep it or else it'll change the value. Okay, after I take 3 out, you might notice that what's left in parentheses here is a square minus a square. So after I took something out, the leftover can factor again, square minus the square. So I'm going to keep the 3 there, 2 sets of parentheses. What are the roots? X and 6. So it's x plus 6, x minus 6. Alright? So it's kind of like a combination of number 1 and number 2. 2 of them together. You should really check first, can I take something out? That's definitely the easiest way to do this problem. At the beginning, I mean, we couldn't even tell if it was a square it wasn't a square minus a square until I took something out. And then, yeah. All right, 23. Uh, 2x cubed minus 8x. Alright, what can I take out of these two? What goes into 2 and 8? 2. How many x's can I take out? Well, they both have at least 1, so I can take an x out. If I divide this by 2x, the 2's cancel out. X cubed divided by x is x squared. Drops an x. Minus 8 divided by 2 is 4. X divided by x is gone. By the way, if I was taking like 8x out of this, 8x divided by 8x is 1. So you'd have to put a 1 there, not nothing. It would be at least a 1. Alright, anyway, what's left in parentheses is a square minus a square. That's actually number 3 right there. So the roots are x and 2, so it's x minus 2, x plus 2. The end. 23. Okay, 25. A5B2. I'll leave the book on this one. Plus 2A4B3. This is a weird one because there's not any normal numbers. What goes into all 3 of these? Well, they all at least have how many a's? They all at least have 3a, 8 cubed. I'm going to take that out. They all have at least how many b's? They all at least have a b squared. I'm going to take that out. So when you divide, really the exponents just subtract. So I'm taking 3 a's out of 5, so that'll leave me with 2. B squared divided by b squared is 1, but 1 times a cubed, a squared is just a squared. So the b's just disappear on that one. The 2 is not divided by anything, so it's going to stay a4 divided by a3, a, b3 divided by b2, b, a3 divided by a3, gone, b4 divided by b2, b2. Alright, what is in parentheses is still a 3-term thing that can be factored. There's no number in front of the b squared, which means there's a 1 right there. Okay, so looks a little bit different, but basically you just kind of ignore the b squared on the end. On the front, it's still going to be a squared, so it's a times a, so that's normal. On the back, it's what multiplies into 1 that adds up to 2. It's 1 times 1. But instead of putting plus 1 and plus 1, because there's a b squared there, you're going to put plus 1b plus 1b. So that's the only thing that changes. And actually, I'm not going to write the 1 down because it doesn't matter. So that would be it. If you FOIL this, it will go back to this thing up here. So if there's like a b squared or something at the end, you kind of ignore it for a little while and just put it in. That wasn't a good one to do first for that kind. 27. 27's a better one. Alright, so it's 3-term. Okay, notice on the last couple there wasn't a number on the front, so this is the easier kind. That's good news. What goes into b squared, that goes in front, b and b. So since it's the easier kind, ignore the c squared for a second. What goes into 25 that adds up to negative 10? 5 and 5 works, but it adds up to positive 10s. But negative 5 and negative 5 multiplies to positive 25 and adds up to negative 10. So 5 and 5 doesn't add up to negative 10, but negative 5 and negative 5 do. Okay, but since there's a c squared there, what goes into 25 is negative 5c and negative 5c. So instead of just putting minus 5, I gotta put minus 5c on both. So it's really like number 7. The only difference is I put a c on it the last two terms. Okay, 29. 150 y4 minus 6y squared. Alright, does anything come out of both of these? Well, usually the biggest thing that could come out of both of these is 6, right? Because the smallest number goes up to 6. So I would check and divide by 6 first to see if it works. 100 divided by 6, I believe, is 25, so it does work. How many y's come out of both of these? They both have at least a y squared. Divide it out. 150 divided by 6, I said was 25. y4 divided by y2 is y2. Okay, what's 6y squared divided by 6y squared? 1, not 0, 1. So it is a 1 right there. Alright. This thing in parentheses is actually a square minus a square. What's the square root of 25? 5. But what's the square root of 1? 1. So 1 is a square number, because 1 times 1 equals 1. So this can factor. So what are the roots? It's 5y and 1. So it's 5y minus 1, 5y plus 1. And that is that. Alright, couple more. Almost there. This is, you can consider this kind of a 2-day assignment, so if it seems big, that's kind of why. Alright, 31 has a weird trick on it. Can I take anything out? No, nothing comes out of 1. Taking a 1 out is like doing nothing, so nothing comes out. It is a square minus a square though, right? What's the square root of the x to the 4th? What times itself equals x to the 4th? X squared. What times itself equals 1? 1. So x squared minus 1, x squared plus 1. Here's the thing though, if you look at this first factor, it also is a square minus a square. So it's going to factor again, this one will. This one will not factor again because it's a square plus a square, which is not factorable. So this is going to stay the same, this one will factor again. So what are the roots? X and 1. So it's x minus 1, x plus 1. And this thing will stay the same, x squared plus 1. And that's that. Alright, last one. Let me see if there's any evens like that actually. 30, no. 32, no. 34. Ooh. Alright. Yeah, we're good. So, yeah, I didn't see any evens that were like number 31, so we're good. 33, 12x cubed plus 104x squared. Minus 36x. Alright, this is a big mess, but if you take stuff out first, that'll help. Okay, well, the biggest thing that could work in everything is 12, But if you do 104 divided by 12, that wouldn't work. What else goes into 12? The next biggest thing is 6. The 6 divided by 104 divided by 6, no, that doesn't work. Next biggest thing is 4. Yeah, that if you divide a 4, that will work on all these. And they also all have at least an x, so I'm going to take an x out. So if I divide that by 4x, I get 3x squared. 104 divided by 4 is 26. X squared divided by x is x. 36 divided by 4 is 9. The x's go away. So in parentheses, I see a 3-term, so I'm going to set up for 3-term factoring. This is the harder version because there is a number on the front. So I'm going to put 3x and x in the front. That goes into 3. And what goes into negative 9? Well, you could say 3 and negative 3. But if I do like 3 out here, that'd be like 9 minus 3. It's not going to get me up to 26. What is going to get me up to 26 is if I use 9 and 1. Because if I put a 9 out here, that's going to get me 27, which gets me pretty close. And then if I put the minus 1 there, that gives me 27 minus 1, which is 26. Okay, so if you're not sure, you just got to try different combinations of what goes in negative 9. 3, negative 3, 9, negative 1, all those, until you get that. Now, it is possible for these problems to not be factorable. On the worksheet there were, I think, like 4 things that weren't factorable at all. But on this assignment, everything does factor. Okay, that's the last odd. So, why don't you guys give that a shot? Good luck. You can email me if you have any questions.